Morning, everyone. Hopefully you feel pretty good about your test yesterday. I haven't had a chance to really look at them yet. I have some online Math 8 tests I got to get done, and then I'll get to your guys's. So I'm hoping probably like Monday over the weekend, probably get to those and be able to grade them all up and hopefully be all caught up. But we are going to start Unit 4, which is Systems of Equations. Now, Systems of Equations is something that you usually get a little bit in 8th grade. I teach it, but I'm not sure how much you guys know. So, a system of equations will look something like y equals 3x minus 11 and y equals 5x plus 10. And they want you to solve them together, right? And so today what I'm going to do, just pretty quickly, is kind of just talk about what are we looking for, what's going on with the system of equations, and we're going to talk a little bit about inspection. Inspection is kind of like knowing how to answer it by just looking at it. So we're going to talk about what inspection looks like and how we can kind of use that to our advantage, okay? So if you look at what we have here, we have just two lines, right? They're both in slope-intercept form. They don't necessarily have to be in slope-intercept form, but we're going to talk about linear equations. So we're going to have systems of linear equations. They're all going to be linear. So they might be in standard form, they could be in point-slope form, you know, whatever. But we're going to have an x, we're going to have a y. And when we're looking for a solution to this problem, what we're actually looking for is, here's two lines. The solution is going to be the point where those two lines intersect somewhere. So our solution here is actually going to be an ordered pair of where these two lines are going to cross. We're going to talk about, there's three ways that we can solve those things that we are going to talk about together. We're going to talk about graphing tomorrow. We're going to talk about substitution. We're going to talk about elimination. If you're smart right now and you're at home thinking, Mr. Odie, can't I just throw those both into Desmos and get the solution where they cross? You can. But we want to be able to do all three of those methods so that when your ACT comes around, you guys know what you're doing when they're like, hey, solve with substitution. So I'm going to show you all three of those and kind of talk about what we're looking for. So the first thing I want to talk about today, just kind of in general today, is we have some different situations that could happen here. Because if we're thinking about two lines, there's really three things that can happen with our two lines. Right? I could have those two lines. This is just going to be a straight rough sketch here. But this one starts at negative 11 and goes up 3. This one starts at 10, goes up 5. It's like real steep, right? Well, if you notice, these two lines, they're going to cross somewhere down here in quadrant 3. I don't know where that's at exactly. But the point is that these two lines cross, which means that I'm going to get a solution in this situation. Now, the important thing is that we don't always get one solution. In fact, just like when we solved equations, we could have infinite solutions, and we could also have no solutions. So let's talk about what those are going to look like, and how we can kind of tell when I'm looking at these things what I'm going to do to solve them. This marker looks like trash. Let's see. See if I can find a good one here. All right, so let's say y equals 2/3 x plus 9, and y equals 2/3 x plus 22. Now, from what we already know about these two lines, if you think about it, we actually know quite a bit. We know their slopes, we know their y-intercepts because they're both in slope-intercept form. And maybe even a little bit more telling is if we look at their slopes, we see that they're the same thing. And hopefully you guys at home, if I'm doing a good job, you're sitting there in your head thinking, Mr. Odie, if they have the same slope, then that must mean they're parallel lines. And you're exactly right. Because these slopes are the same, we've already talked about that parallel lines have the same slope. So when I ask you, what's the solution to this system of equations, you're thinking, where are those two lines going to cross? Well, since they are parallel lines, they're not going to cross, right? That's the whole point. So this, without even solving it, I can tell you there's no solution here. All right, so here's what I want to write in my notes. Parallel lines are no solution. They're never going to cross. That's what they mean. So I'm just going to write a little note to myself. Same slope, different y-intercept. Right? If they have the same slope, but they have different y-intercepts, those two lines are going to be parallel. They're never, ever going to cross each other. So when I'm looking at inspection, I'm going to look at two lines and say, hey, do they have the same slope? If they do, are their y-intercepts different? I know those are two parallel lines somewhere. Now, we might not have that for our system. We might have one that looks like this. Y equals negative 6x plus 4. And then we might have 2y plus 12x equals 8. And now I see, oh no, that second one, that's not in slope-intercept form, is it? I know you guys got a little bit of a glare here. Let me pull it in close. That helps. All right. So, not in slope-intercept form. All right, well, let's rewrite this one. So I'm going to minus 12x from both sides. That gives me 2y equals 8 minus 12x. Now I can divide by 2. Right, we know how to do all this. 8 divided by 2 is 4. Negative 12 divided by 2 is negative 6x. And then you may notice, by looking at these two lines, hey, those have the same slope. And not only do they have the same slope, they also have the same y-intercept. So really what we have here in this system of equations here is we have the same line twice. Okay? And if you think about what that looks like, if we're talking about where do these two lines intersect, they intersect everywhere. They're going to be directly on top of each other. They're just going to continually cross. So this idea is my infinite solutions. They will constantly cross each other. So therefore, they're going to intersect at every point possible. So if they have this, let's say, if they're the same line when you're done, and what I mean by that is, I guess I'll just write infinite solutions. And what I mean by that is they have the same slope and the same y-intercept. All right? Though, that's how you're going to get your infinite solutions case. If it's the exact same line. Now, normally they'll kind of hide it like this, and they'll put one in standard form or something. You're going to have to rewrite it and see that they're actually the same line. But if you end up with the same line, there's your infinite solutions. Parallel lines is your no solutions. And then, how do I know if I have one solution? Well, that's pretty much all the rest of the time. But a really good way to think about it, 9x plus 5, y equals negative 6x minus 31. A really good way to see that you're going to have a solution is when those two slopes are different numbers, they have to cross somewhere. The only way they don't cross, or if they cross on top of each other, is if their slope is exactly the same. So otherwise, if you have slopes that are different, you're always going to get one spot where these two lines cross. So this we would just call one solution. And I don't know what it is, I'm not actually finding it, but I'm going to tell you that, hey, those two lines are going to cross somewhere. And that's if the slope is different. All right, so that's kind of the basics on systems of equations. We're going to do some really fun math because I love substitution. It's one of my favorite things actually in all of math. I don't know if later we're going to long divide by polynomials or not, but that's like probably one of my favorite things in math too. But substitution is really fun math. And we're going to talk about how to actually find these solutions. And Unit 4 is a pretty good unit. I like a lot of this stuff. So this is kind of the jump off. All right, hopefully that helps. I gave you like a little worksheet, I think, for homework. So yeah, why don't you go do that now, and I'll check you guys out later. Peace out.